able to see? Those who are online, are you able to hear me? Lokita and Varshini.
Yes, sir.
You're able to see? So those who are online, can you please confirm if you're able to see?
Yes, sir.
So initially, right, I just wanted to start with some, instead of directly going into the chapters, I thought first we'd discuss a little bit of what you're going to have in your level. You will be having a certain test, the subjects will be dealt in a different way. So I thought I'll give you a little bit of clarity on what exactly is going to be there. Then we can think of getting into the chapters. Right? So if you see from your 10th to 11th, right, what do you expect? What do you expect? Do you expect any change to be there, or do you think it's going to be the same way where you get science as a whole in your 10th standard? Do you think it is going to be the same in your 11th as well? So firstly, you will have observed this. In your 10th, you have science as a whole. Is that right? Means you have math, physics, and chemistry all put together as, sorry, not physics, chemistry, and biology all put together as one subject. Right. But when it comes to this year, right, 11th standard, you're going to have each subject as a different department, I would say. Well, math is almost the same. Like last year also, you almost done 15 chapters. This year also, you have done 15 chapters. But when it comes to science, right, science is basically, I can say, tri-sector. Okay, you do physics separately, chemistry separately, and you have your biology also separately, where each subject is going to have approximately, any guess of the number of chapters? Each subject. So last year physics you had 5, out of which I think sources of energy were deleted, so you had 4. But that was even broken into term 1 and term 2. Now I don't think we are going to have these term exams. So keeping that aside, right? You know any idea how many chapters are going to be there? You have around 15 chapters. So similarly, chemistry you have somewhere around 16. Biology it's a different story, and math you have around 15. Okay. So having this, right, not to scare you or something, there is a slight elevation. So that is how the syllabus itself is. So when you see your 9th standard, right, can you recollect what chapters you had in physics? Can you recollect and tell me? At least the name of the chapter, I'm not even getting into the context. But mainly discussing about motion in one dimension. You are concerned about an object moving along one dimension. Then you had something called as laws of motion, where you were discussing about the Newton's laws, right? Apart from that, you had work, energy, and power, right? Then you had gravitation part, in which you learn about fluid mechanics also, like Archimedes principle, right? Then the last one was sound. Sound alone. So sound you have it as wave. So if you see, right, this is the syllabus that I have kept in front of you. So this is the syllabus for 12th standard, I mean the 11th standard, where these are all the chapters that you have. So let's try to understand how exactly your syllabus is. And the reason I didn't ask about your 10th, and I asked about your 9th is because 11th is actually an extension of 9th standard, and 12th is an extension of your 10th standard. So that is how the syllabus works. Except the fact that when you generally go with the 9th and 10th, right, the foundation parts, you would have not worried about why a particular law is defined only like this, or why a particular formula has come out in this way. For example, you have another formula. 1 by v minus 1 by v plus 1 by u is equal to 1 by v. Right? But if I put a question to a 10th standard student, you imagine yourself a 10th standard student, will you be able to answer that question of how did you get it? It's not your mistake because it was not a part of your syllabus also, right? But actually, you used a bit of math to get that answer. You have to be precise, right? You use something called as similarities of triangles to generate that value, or basic trigonometry to generate that value. Basic trigonometry. Right? In a similar way, if you see in your 11th standard also, there is a little bit demand for math. So you need to have a little bit understanding and control over your math to solve certain problems in your physics. So when you're studying, right, first thing I would advise you is don't read physics as physics and chemistry as chemistry or math as maths. Try to link the subjects only. That is what, as teachers, our team will try to give it to you, but make the best use of it. In the sense, what I want you to do is ask as many questions as possible and don't accept anything that is told you. If I tell you a clearly put a question of why this is happening and how did we even arrive at this particular conclusion, I want you all to speak out and have as much interaction as possible and not concerned about other places or wherever you are, not concerned about your school or anything. Only thing is, you can feel free to ask questions not only to me, but any of the teachers who's going to stand here and teach you. Is it clear? So feel free, feel confident, okay, and have the sessions as interactive as possible. So this is the basic outline. So if I have to give explanation of each part, right, let's try to first understand based on the name of the chapter itself. Okay. Shall we try that? Right. So if you look at the first chapter, right, what do you have? You have something called as physical world and measurement. Right. So before you learn any chapter, two important questions to be asked. What is the chapter all about? Why are we studying it? Okay. So there is a reason why your syllabus is like this. As I told you, one of the points is from the extension of your 9th standard is what is 11th standard. But if you see from the right hand side, right, it is actually the first year of your degree. So you'll be learning the same thing in first year of especially engineering part. The same topics will almost come there. So that time it will become easy for you. Means you can concentrate on bigger things if you try to understand the bigger parts now itself. Is it clear? So when you try to see what is physical world and measurement, what do you think we are going to deal with? There is something given at the bottom. Chapter 1 name is physical world. Chapter 2's name is units and measurements. So what do you think is going to be there? Can you guess? Any guesses? Physical world has any idea what we are going to do? So if you see this, the first part you will see what is physics all about and what are the different branches present in physics. So can you tell me some of the branches which you know? So you have mechanics and you have electricity, electronics, and you have electrical. So all the engineering parts basically are borrowed only from physics, right? So you will be trying to understand what are the different branches that are present and in those branches what we are going to deal with. Okay, so anyways, if you see the chapter, it is not like there is a point in explaining it at the beginning itself because you are going to learn the same thing throughout your physics. At that point, if you discuss, it is enough. Okay, generally, we will not spend much time on physical world. Second is, you're able to see something called as units and measurements. What is that? That is also, so you have a name that is giving you an answer. Units and measurements. What do you mean by that? So when I say units, right, what comes here? Do people have drawn graph? So when you draw a graph, right, you write something called as scale. You write something called as a scale on right top corner. You write x-axis 1 centimeter is equal to 1 unit. Y-axis 1 centimeter is equal to 1 unit. Have you ever asked the question of what unit are we trying to speak about? Told you wrote it. That's the fact. Did you ever think of what unit we are trying to talk? In the first place, why are we even drawing graphs? Didn't ask. So that's what I need to ask. Okay. So, but left hand side you wrote something 1 centimeter. Now, where did that centimeter come from? Why did you write 1 meter is equal to 1 unit? Why you wrote only 1 centimeter is equal to 1 unit? So the box is there, that is actually a square of 1 centimeter. So in that box, you take 1 centimeter and you can associate it with 1 unit or 5 units or whatever you call it. So that 5 unit is there, right? That unit can be anything. It can be kilometer, it can be meter per second, it can be meter per second square, or whatever it is. That is why we generally call it as a unit. So that is what we are going to discuss. As units and measurements. So for which quantities you try to write units, or quantities which you are trying to measure. What we are discussing about measurements. You see, for example, you go to a shop, okay, when you buy something. Let's say you're going to a provisional store, a supermarket. Generally, when your parents ask you, right, you get rice and come. What is the first thing you ask? Let's say you're going for a. What is the first question you're supposed to? What quantity of rice is needed? Right? Depending on the requirement only you're going to buy. You're not going to buy the whole stock and keep it, right? So when they say how much, when your parents say a number and leave it, or they will mention something else. They will say these many kilograms of rice is needed, right? So for that, you have, if you keep physics aside, right, don't you think, see, the shopkeeper has nothing to do with physics. Do you think he has? His job is only to put the weight scale there or have an electronic machine where he will keep something on it and measure the value and he is going to give you. Right? He has nothing to do with physics. But as an end user, what are we trying to do? We're trying to communicate. So when you need to communicate, what is the most important thing? The language. So what I'm trying to say is physics also has a language. In that language, when you try to talk to another person, you have certain rules to be followed. For example, you cannot go and tell the shopkeeper, I need 5 rice. 5 rice means he will give you 5 grains of rice, or 5 grams of rice, or 5 tons of rice. So you need to be specific about something called as units. So that is the reason why this chapter is actually there. So units and measurements, what we generally do is we are trying to understand what are all the different forms in which units can be represented, what different measurements that you're trying to take. Okay. So the next part, if you see, unit 2 is what? So you say kinematics. What is kinematics? Any idea of what is kinematics? Under that, what are the chapters you have? Something which you have already learned. What is it? So you learned about motion in a straight line, did you? When you have motion in a plane. So motion in a straight line is again an extension of what you have learned in your 9th standard. Right. So you can also call it as rectilinear motion. Have you heard of this word? Rectilinear motion. Linear. Linear motion is step motion, one time motion. That's what we are going to see here. But the fact that we are going to apply little bit bit of what I want to say, more of mathematics to derive those formulas. You have three formulas. At least be able to recollect when I say V is equal to U plus AT, S is equal to UT plus half AT square, and V square minus U square is equal to 2AS. You have heard of them, right? Have you ever tried to derive them? Or you just applied it? Yes. So there is a derivation, even for 9th standard, you can derive it using the graphs. So what we will do here is we use a little bit of mathematics and derive those quantities and try to apply them. Okay. Then you have something called as motion in a plane. So what is plane basically? Two dimensional. Line is one dimensional, plane is two dimensional. So if you are having an object which is moving in a plane, for example, I'm talking about an object which is moving in the plane of this board, then I can call the job. Then I can say that the object is moving in a plane. Okay, about that we are going to learn. So next chapter is also a famous thing which I have already learned, laws of motion. So in laws of motion, what we will do is we will be concerned more about something called as force. So how do you apply force to make an object move? So in which, if you apply force in this direction, in which direction will the object get to move? We'll be trying to break our heads to understand this kind of, to answer these kind of questions. Okay. Then we have work, energy, and power, which is also not new. So you have force, and you apply a force on an object, and it has some displacement. Then you say work is done. So that work, energy, and power. So to do this work, how much energy do we need? By doing this, what is the amount of power we are able to generate? Is what we are going to learn in that chapter. So something which is new that we are going to learn this year is system of particles and rotational motion. It's a very interesting chapter, at the same time slightly technical chapter where we need to deal with utmost attention. Okay, it's a good chapter actually, where you'll be learning about something called a center of mass, center of gravity. You have heard of these words, right? But you will try to answer how do these points vary for different kinds of objects. See, for example, this bottle is there, right? You're able to see this bottle. I'm able to see it's very heavy because it's filled with water. So I give you this bottle. I say, find the center of gravity of this bottle. See, for example, I take this pen. Okay, I want you to find the center of gravity. Will you be able to answer that? If you know this chapter, yes, you can do it. It's a very simple thing. See, how many of you play sports? Especially badminton. You guys play? So you play, no? At least at times you play. So who bought the racket? You went to the shop and bought it. Your parents bought it and you're using it. They bought it and you're using it. As a science student, if you go after learning the chapter, you will have a better clarity. Because you know about how to find the center of gravity of the badminton racket. Okay, based on where the center of gravity is there, whether the badminton racket is going to help you to play from the front or you can play from the back. So if you're a player who's taking more number of smashes, then what kind of a badminton racket you're supposed to choose? So these are all the things that you will get answers for. This is not a part of your syllabus, but that's what we'll be discussing. Are you able to understand? Okay, just I asked you a question, right? If you want, you can try this and see. When you go home, take a badminton racket and try it and see. If this is a racket, okay? If you try to hold it at some point without the pressure, it will start rotating. Why? Because something is unbalanced. This side, the mass distribution is more due to which it is revolving this side. Okay. Now, if I move my hand slightly this side, it is still revolving. Right? So if it is here, it is revolving this much. If it is here, it is still revolving. Maybe if I remove my hand, it will be able to revolve. So if I hold it this side, see what is going to happen. What has happened? The direction has changed. Means between these 2 points, you will be able to find a particular point where it will get completely balanced. And this point is the center of gravity of the sun. Same logic is applicable to badminton racket as well. If you have it, go study about it and try to find it. So based on that, I want you to study what is a head-heavy racket, something called as a head-light racket. Means that head is there, no? If it is heavy, means how you can play. If it is light, means how you can play. Those of physics will help us to understand this. Okay, that's what we'll be reading about in system of particles, and there is something called as rotational motion. So when you talk about rotational motion, right? It is one of the most important branches of mechanics. For example, this fan is there, which is rotating. It is revolving, right? Similarly, you have a car or you have a bike. When you accelerate it, what happens? When you accelerate it, you can see that the wheels revolve. Means you are creating something called as torque. Have you heard of this word torque? Have you ever seen the meter where it shows the speed of your car? So there will be written as RPM. Any idea? It is number of rotations per minute. It depends on how much acceleration you are giving. The torque is created and the wheel will rotate very fast. Whatever you study here, right, it is mainly applicable in automobile industries. So that is the most, if you ask me, that is my favorite chapter and one of the most important chapters also. It's not, I'm not saying it is because my favorite, but it has a lot of interesting content. Okay. Then gravitation is something which is not new. What is gravitation? We'll be studying about how objects are pulled by different planets. Okay. So that's what we'll be dealing with. And if you look at it, there are two volumes actually. We have covered the 8 chapters. The second volume, if you see, it is mainly concerned about properties of different materials like solids, liquids, and gases. So if you see, the first one is something called as mechanical properties of solids. Means when you apply a force, when you apply pressure on an object, how do the solids respond to force and pressure? Is what we need then. Mechanical properties of solids. Similarly, you have mechanical properties of fluids. So when you talk about fluids, right, if you keep a fluid in a particular container and dip the solid into it, how will the fluid respond? What kind of elastic property it has? That's what we'll be dealing with. And thermal properties of matter. Here you see matter in the sense you can talk about all the 3 substances: solids, liquids, and gases. We'll see how solids, liquids, and gases will respond to different kinds of temperature changes we are trying to create on them. Okay. Then you have something called as thermodynamics. So thermodynamics is all about, again, if you go back to your vehicles, right? When you start a vehicle, what is happening? When you have an automatic starter, the engine gets ignited. Right? Based on the engine getting ignited, there will be some kind of a work which is being done on pistons. Piston is something which will get compressed and expanded. Okay. So that is able to make the whole process work, and you are able to make the vehicle. Is it clear? So thermodynamics, you see how heat can generate some useful work. So when I say use the word ignition, right, a spark is created. So that spark is creating the heat. And how is that heat able to get converted into some useful work is what we are seeing in thermodynamics. Okay, that also has a lot of application in mechanical engineering. Then you have something called as kinetic theory of gases, which is, I will call it as an independent chapter. We'll be studying about how the particles inside a gas are responding to different kinds of temperature. Then you have something called as oscillations and waves, which is also important for your next year. Right, sound you learned about. You know that sound is a wave. What kind of a wave is it? That starts with L. It starts with L. It's not a longitudinal. You've heard of this one, longitudinal and transverse waves? No? Actually, it is there in your slide itself. Sound is a longitudinal wave. So we'll be discussing about waves and oscillations at that point of time. So I'm getting a picture of what exactly we are going to study, right? So what I'll be doing mostly is to do, yes, exam marks, everything I'll be concentrating upon. Apart from that, I'll also try to teach you with more of practical examples. If you guys can also do some research and come and discuss, it will be more interesting. Do not feel bored. That is what the first objective of you studying this 1 year should not be bored. You should enjoy and study. And with this, can we get started? Yeah. So we get started with the second chapter, that is units and measurements. So right on the heading. Done. So please give me a minute. Listen. So for this chapter, I've already given you the introduction. So the introduction is why are we studying this in the first place? It is mainly to understand how measurements are taken, and to the calculated measurements, what are the units that we are supposed to give so that everybody is able to understand. We are only trying to understand the language of the physics classroom. Okay. And one more important point in this chapter is when you take a measurement, right? Any measurement in this world, except this machine made, generally when we take it, right, there will be some kind of error that is occurring. No one can do 100, no one can be 100% perfect. So when that error is there, we will also try to calculate how to calculate the amount of error that we have generated. Okay, or the process that we followed has generated. Okay. So that's all about this chapter. That's what is given in the introduction also. I'll just read it out. So you say we observe many phenomena. Phenomena is something that you can see and feel. Right? Occurring in our surroundings. Some are natural and some are man-made. Okay. But basically, if you want to describe any phenomena, then what are you supposed to do? You need to take the measurement of that particular physical body. Is that right? So just a minute. So what will we discussing? So we have different phenomena which are man-made or naturally occurring, and depending on that, right? What we can do is, if you want to quantify that value, what will be by quantify? Quantify means quantity. If you see, where is it derived from? Quantity, right? So quantity is some amount of measurement that is being taken. So if you're able to quantify a particular phenomenon that is able to happen, that is happening, call that quantified value as measurement. And that measurement needs to have a unit for us to communicate. So let us say there is an example where there is a fruit that is falling from a certain. There is a fruit that is falling from a certain height. Is it a naturally occurring phenomenon or man-made? It's a naturally occurring phenomenon. Let's say somebody has cut the apple at the fruit at the top of the tree. How is it able to fall? Because of naturally occurring field around it called as gravitation. So due to the gravitational field, what is happening? The object is being put towards the center of the earth. Is that clear? This is what we more technically call it as free fall. Have you heard of this word free fall? So free fall is where an object is traveling under the influence of gravity. Okay. So we will try to measure certain values. Let's say I'm cutting a particular fruit and I'm giving you a stopwatch. Why would you use a stopwatch in the first place? To calculate the amount of time that particular fruit is taking to hit the ground. Okay, you might think, who is it that do all these things? Why am I even concerned about that? Maybe it is a prototype for some other experiment that you want to do. Let's say the fruit is of particular mass, and you want to see how fast the fruit is able to travel in that particular distance. Maybe you use it for some other thing. You use a similar kind of an object of the same mass for some other purpose. Right. So for these kind of things, we need to do experiments. Right. Now, second is you try to understand what is the speed with which the fruit is hitting the ground. Right. When you have these kind of questions to be asked, right, then you need certain formula to measure the values, and that formula will give you the measurement along with something called as units. Okay. So that's what we are saying. We need to measure the physical quantities like distance, time, mass, etc. accurately. So for measurement of any physical quantity, we require to decide their appropriate units. See, for example, when you talk about velocity, right, or speed of an object, I asked you about the car example. So in the meter that you're able to see, what is the unit that is there? It is written in terms of kilometer per hour. Why not in terms of meter per second? So generally, what is the purpose of the car? The car is not used to travel for seconds. You generally travel for hours and you try to cover kilometers. When you're doing kilometers for a few hours, why do you want to measure something in meter per second and complicate things? So there is a particular unit selected for car. Similarly, they don't measure it as something like meter per hour also, because you're not going to cover in terms of meter, right? So in this chapter, we study how the physical quantities are measured and how different units are defined. We'll also learn about different types of errors associated with measurement of physical quantities. I have no problem with it. Right. So if at all, right, till now we've understood that something called as measurement is there for which unit is necessary. But if we need to write or give a conclusion saying that what exactly unit is, then we need to write defining it. Right? That is what the second part is about. Can you write down the heading? What should be the unit of a physical quantity? Okay. If you have to give the simplest definition possible to you, right now you got an idea of why units are there. Why are units there? For defining measurable quantities. Right? So if you have a standard measure, why do I use the word standard? What do I mean by standard? Standard is high quality. Is that what I'm trying to? Standard means standardization, means universally followed. So if I have a standard measure of any quantity, means if I have a universally followable unit which a measurable quantity has, then I can call that particular value, or you can call the word as That is the meaning of it. Please write down the definition. The standard measure of any quantity is called unit of the physical quantity. I hope you are able to understand this. The standard measure of any quantity is called unit of that physical quantity. So what is physical quantity? Something that can be measured. Okay. And there are certain properties which unit should possess. What are the properties that it should possess? First is, if you give the measure of any unit, right, it should be a definite value and it should be unambiguous. What is ambiguous? Something which is confusing. Right? It's not like either this can happen or that can happen. You should not be put under any kind of a confusion. What is needed? You need to be specific. Okay, if I give you meter per second, I cannot say, like you should not get confused whether it is for this quantity or the other quantity. You have to understand what it is. So it should be only for speed or velocity. It should not be for some other physical quantity where it is confusing. So that is why you see the measure of a unit should be definite and unambiguous. That's the first point. Second is, so you can write it along with it. When I'm saying, you can also make a note of it. What is the first point? The measure of unit should be definite and unambiguous. Second, okay, the unit should be such that its measure should not change. The unit should be such that its measure should not change. And if the unit is defined, with the help of some phenomenon, then the phenomenon must be permanent. So unit is defined with the help of some phenomenon, then the phenomenon must be permanent. That's what we are trying to say. Is it clear? See, the example of it is, let's say you want to measure the length of something. You want to measure the length of the string. Okay. Then you take a scale, right? They're trying to say, when you take a particular scale, the way you measure that value, in the sense, the scale should be designed in such a way that the distance between 1 centimeter should be broken into 10 millimeters. Means they should be equal, not like one scale has the distance to be small, one scale has distance to be more. So that is the phenomenon that we are following. To measure something, we need a tape or a measuring device or whatever you call it. If you are using that phenomenon, you need to ensure that it is a standardized process so that everybody is able to use it. Have you ever seen carpenters measuring at your home? Have you ever seen work happening? Right? Generally, when they try to measure something, they'll have a big tape. They'll pull it like this and measure it. So maybe the design of the tape is different, but if you see the value that is written on top of everything is the same. So they follow a standardized procedure. Or else, what do you think would be the problem? If the standard was not there, what would have been the problem? Why do carpenters work? What do they do generally? They do some woodwork. They mainly work with wood, right? So, for example, you are able to see, you are sitting, you are using a plywood to write. So, that plywood, if you see, it has a particular measurement associated with it. If they had different kinds of tape, then what would have happened? If one carpenter is working and taking a measurement today, tomorrow someone will come to repair it. Then that tape will give him a wrong reading, and whatever work he is going to do is completely going to be different, and it is a loss of property for us. It has serious impacts also. That is why the standardization is the most important thing. Generally, when you look at them, right, they always try to measure it in terms of inches. When I try to talk to them, right, I speak in terms of feet. They speak to me in terms of inches. We get confused. So that kind of thing is there. But inch or feet both are measured for the distance, the length, right? So whichever is convenient for you, you can use it. Third one is the prototype of a unit should be easily reproducible and easily available. The prototype of a unit should be easily reproducible and easily do something similar to the second point. After this, can we proceed to the next one? So now you understood what are the units, right? What did we say? The standard measure of any quantity. That is what the book definitions. Okay. But we try to understand with certain real-time examples also why it is important for us. Right. Now see, what do we mean by units of physical quantities and what are the systems of units that are being followed? Okay. So what do we mean by units of physical quantity? We'll try to understand it. So if you see, there are a number of physical quantities that are there. Can you give me some physical quantities? Sure. You try to measure in a day. Sorry. Bending. Centimeter, that is the unit. I'm asking what is the physical quantity. Centimeter is used for what? For length. Right. So length is a physical quantity. Centimeter is a unit. Okay. So generally when you do right, suppose you want to come from your place to here. Okay. Generally, if you want to start from your home, let's say you're booking some cab or something. First thing what you do is you try to measure this. You will understand how much distance you are away from. Based on that, you will calculate your time of when you are supposed to start. Right. That is when you book the cab. If the cab is at 5:30, you will not book the cab at 5:30. You want to reach here by 5:30, you will calculate how much distance from your place. So for that, the distance is called as a physical quantity. And generally, the distance we are trying to talk about might be in terms of few meter if you're staying nearby, or might be in terms of few kilometers. Is that right? So the distance is a physical quantity, meter or kilometer is a unit. So that's what the topic is about. See, what do you mean by units of physical quantities? Physical quantities are the ones which are measured. Similarly, you will calculate the time. So you need to know how much time it is going to take for you to come from your home to here. Only then you can estimate when you're supposed to start. So the time is a physical quantity. The time can either be in terms of seconds, minutes, or hours. So that is a unit. So here. Then lastly, if I have the data of these two, then you can measure how fast the cab or your vehicle, whatever vehicle is going to, how fast or slow the vehicle needs to travel, which will give you something called as speed or velocity, which is measured in terms of meter per second or kilometer per hour or whatever you call it, centimeter per second, whatever it is. Right? So I hope you got a grip of what is physical quantity. So something which is measured as physical quantity, and after the measurement, you will give a prefix. 5 is the value, for example, 5 kilometer. 5 is the magnitude. That is the value of the quantity. Kilometer is a unit. That's so unit. Is it clear? So that is why you see, although there are number of physical quantities. Right. For example, now itself we discuss about distance, time, speed, velocity, displacement, all these things. These are different physical quantities. Generally, they are very large. If you look at the table, right, it will go very big. If you prepare a table like this, first distance, second displacement, if you prepare a table, it keeps on going. Like for everything, you need to design a proper system. System in the sense of a following, I can say like a rule book, where you say, if this particular quantity is measured, I need to use only this unit. Or else what will happen? If I come and tell you velocity is 5 kilometers, will you accept it? I am not confusing you. Because there is a standardized unit. That's what the book says. And we have to follow that, right? So since we have these many number of physical quantities, we had to form a system. They had to break their heads to understand how to make sure that the physical quantities have only these units. But here also there is a problem. That is, you have so many physical quantities. Means can you implement so many methods to keep measuring it, or is there a possibility that you take certain values combinations and combinations to that value to get the output. So for example, if I want to measure distance or displacement, I'll be using only meter. If I want to measure time, I'm going to use second. SI, right? And if I'm measuring velocity, if you see, it is a combination of distance and time. How is it? Meter per second or displacement by time, meter per second. So they took the SI unit from there, they took this side SI unit and combined it in such a way that first SI unit divided by the second SI unit will give you the SI unit of velocity. So this is a combination, right? Similarly, if you look at acceleration, it is velocity by time, meter per second, and you divide it with second, you will get meter per second square. Again, meter is derived from distance or displacement. Second square comes from time. So they combine these two. So what we generally do is we will try to fix that these are the base quantities. And based on how these base quantities are combined, in the sense whether they are multiplied or whether they are divided or they are divided raising the power to some X factor. Based on that, what happens is different kinds of units are generated. Are you able to understand? So that's what we are going to see. Now you read the statement, it will make more sense. Although there are a number of physical quantities, so although the number of physical quantities is very large, we need only what? Minimum limited number of physical quantities for which units should be the units of all other quantities. Means I will take only those quantities which I feel is important, where I can derive all other physical quantities by combining these quantities itself. Are you able to understand? Then those quantities which are used to write the bigger values are called as fundamental values. Why do we call it as fundamental? Because they are the basics, right? So we have something called as fundamental units and something called as derived units. Okay, I'll come to that. So limited number of physical quantities for which units should be the units of all other quantities which can be expressed and defined with their help. Okay. So the minimum physical quantities that we are trying to talk about are called as fundamental quantities, and the quantities which are able to write with the help of them is called as derived quantity. Derived. Okay, are called. The other quantities can be expressed as a combination of fundamental quantities. Such quantities are called as derived physical quantities, and their units are called as derived units. Okay, even before you write. Can you tell me what are the fundamental quantities from the example that we discussed? If I talk about distance, distance is measured in meter. So is it a fundamental quantity or is it a derived quantity? It is a fundamental quantity. Similarly, you take time, which you measured it in second or hour. That was a fundamental physical quantity. But we obtain something called as velocity by combining these two. Displacement by time. Then I can call velocity as derived quantity. Similarly, acceleration is a combination of velocity and time. I'll call that as derived quantity. So whichever depends on the fundamental quantity is what is called as a derived quantity. I hope you're able to get a picture of what I'm trying to say, right? So please make a note of it. So write down the point. The minimum physical quantities, I'll tell you the reference. We'll go copy from there. Right? The minimum physical quantities with which we can derive other physical quantities, are called dash. What is it? They're called base or they called base, BASE. They are called base or fundamental quantities. Are called base or fundamental quantity. Am I clear with this? Right? Then the units of fundamental physical quantities, the units of fundamental physical quantities are called fundamental physical quantities are called what? They're called base or fundamental units. They're called base or BAST. Okay. BAST, base or fundamental units. Varshini, are you there? Varshini?
Yes, sir.
Yeah, you're able to understand, no?
Yes, sir.
Good. Okay. Am I clear, guys? Yes. So, what would be the next definition we need to write down? Derived physical quantities. So, write down the quantities which are derived, from fundamental physical quantities. Quantities which are derived from fundamental physical quantities are called derived physical quantities. Are called derived physical quantities. Are called derived physical quantities. Is that clear? And the units of derived quantities are called derived units. Write down that point also. The units of derived quantities are called derived units. Right? The next important point is we need to understand what are the different kinds of systems that are already there and what are that we are following today. So at different points of time and different areas, means at different locations of the world, there are different kinds of units that are used. For example, one of the systems is called as FPS system. So generally when you write the name of a system, right, you write it in caps. So F stands for foot, P stands for pound, and S stands for second. Okay. So if you see, foot is a measure of what? Length. Pound is a measure of weight. Correct yourself. It is a measure of mass. Mass is different from weight, right? So second is a measure of time. Is it clear? So where do we use it? The British system that is used here, right? Similarly, you have something called as CBS units. CBS unit, what happens? It is measured in terms of centimeter. C stands for centimeter, T stands for gram, and S stands for second. Right? So if you see in both the system, right, what is the first letter that is corresponding to? Foot or centimeter corresponds to length. Pound or gram corresponds to mass. Second and second obviously corresponds to time. So what are the three fundamental quantities on which other units can be distributed? Length, mass, and time. Right. So later they came. So if you see FPS system, there are three fundamental units. If you talk about CGS system, it has three fundamental units. Similarly, you have something called as MKS system. You can guess it now by now. So M, length measured in meter. K, kilogram. Yes, again second. Right. In MKS system, again you have three fundamental quantities. Right. You have something called as MKSA system. M mass, sorry, M is meter, K is kilogram, S is second, A stands for ampere. Ampere is a measure of current. So they say that some of the quantity is taken in terms of ampere. For example, charge, you can write it in terms of ampere. I'll give you an example. You would have learned this last year. I is equal to 1 minute, guys. So how do you write current as? You write current as, current is measured in ampere. No, I'm saying current, you can write it in terms of charges. So I is equal to Q by T. Can I write it? 1 minute. Charge. So I have I is equal to Q by T, where Q is called as charge and I is current. So I can write Q is equal to I into T. So I is measured in ampere and time is measured in second. And what is charge measured in? Any idea? It is measured in coulomb. So you can say coulomb is equal to ampere into second. So coulomb is a direct unit in MK system. Why did I say coulomb is a direct unit? Because ampere is also a fundamental quantity in MK system. MK SA system, not in MK system. It is in the fourth one. MK SA system. Are you guys able to understand the meaning of it? Right. Whereas in MK system, can I say coulomb is a direct unit? Third one is what? Third one is what? NK system. Can I say NK system? Coulomb is a direct quantity. Why? Direct quantity means it should be a combination of fundamental quantities. In NK system, is ampere a part of the fundamental quantity? No. So in NK system, it is not a direct quantity, whereas in NKSA system, it is a direct quantity. Are you able to understand what is the difference? Right? The last is about SI. That is what we are using today. Right? That is System International. Right? So see, the SI system that we are using today doesn't have the three quantities. So if you see the first three, FPS, CVS, and NKS, how many physical quantities were there? Only three. Whereas in NKS system, 4. Whereas in SI system, you have 7. That's what we are following today. Okay, at least in India we follow. Because in US and all, I think they still use this gallons and everything. They want to fill the gas or gallon is some 3 point some liter. I don't remember exactly, but yeah, they use it. Okay. So what are the base quantity? I'm not giving you the definitions. Will confuse you. I'm not going to tell you about the definition. Let's concentrate on this. So the 7 physical quantities are obviously you definitely need length, mass, and time. Without that, you can do nothing. Length, mass, and time are definitely included. Along with it, ampere is included, that is electric current. Then you have temperature, that is a thermodynamic temperature. Then you have something called as number of moles, the amount of substance. The amount of substance is one of the quantities. And the last is luminous intensity. You know what is intensity? What is it? Brightness. For example, this room is there are 2 lights. Right? You have a specific brightness. This is radiating some value. This has a specific brightness. So this is what is called as luminous intensity. So intensity can be either with sound or light also. When I say intensity with respect to sound, I will say how loud the sound is. You have to understand. So luminous means something related to a luminous object. Means which is a source of light. So for light, intensity means brightness. Is it clear? So what are the 7 quantities based? Let's try to recollect it quickly. Length, mass, time, then electric current, thermodynamic temperature, amount of substance, and luminous intensity. Okay, please make a note of it. So how you do is make a column like this. So we make 3 boxes, or you can write at 3 headings. Base quantity, name, symbol. Base quantity, name, and symbol. So the base quantity, what do you do? Right? So base quantity, what do we have? Length, right? Beside length, so don't copy it vertically, copy it horizontally. Beside length, what will you write? You write the unit, which is measured in meter. Okay, don't write meters. Units do not have plurals. Okay, write it in meter. And secondly, even if it is the name of a person, when you're writing a symbol in expanded form, that that is METRE, when you write it in expanded form, the first letter should always be small. So it should always be the lowercase. Is it clear? So that is when you see small m. So meter is what we write. Okay. Next, the symbol, unless it is a name, it will be in terms of lowercase. Meter is not a name, so that is why you see the symbol of meter is small. We have certain rules to be followed, about which we will be discussing later. So as of now, it is clear now. Mass is measured in. So name of the physical quantity, you can write it however you want. But when you are writing the name of the unit in the full form, ensure you always start with the lowercase. Right? Well, even if it is the name of a person. Okay. So it is kilogram. Kilogram obviously is not name of a person. Kilogram doesn't have any space. And the SI unit for it is kg, where k and g both are small, and don't put a dot beside it. It's not an acronym. You know what is an acronym? So next is time. What is time? Measured. It is measured in seconds. Correct. What I tell you, unit should not have a plural. So it is only second. Okay. So it is second. And what is going to be the symbol for it? Smallest. Similarly, electric current. Measured in ampere. Ampere is the name of a person. So ampere is the name. Write the full form in lowercase AMPERE, whereas the symbol is capital. So name of a person will have the symbol in capital. That is why if you see for force also, when you write 5 Newton, Newton has a capital uppercase. You able to understand? Similarly, you have thermodynamic temperature. Thermodynamic temperature's SI unit is Kelvin. Kelvin is also the name of a person. So write it as capital K. Okay. Next is amount of substance. So you measure the amount of substance in terms of mole. MOL. MOL is the full form. MOL is a symbol. Okay, MOL is the name. Symbol is MOL. Here, similarly, you have luminous intensity, which is candela. 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 Luminous. 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 Intensity. Candela. CANDELA. And symbol is to CD. Both are in lowercase. Is that clear? So, we mainly saw about the 7 fundamental units. Now we'll see about derived units. C is in lowercase. So, all the units, that's what we discussed. No, all the units which can be expressed as a combination of fundamental units is what we call it as derived units. So, can you give an example of it? When you think of velocity, speed is there. I already discussed it. Speed is what? Meter per second, which is a derived unit. So, meter is it a part of the 7 fundamental quantities? Yes. Second, yes. Combination of these two derived. Okay, meter per second. Similarly, if I have work done, you remember what is the formula for work done? I asked about the formula for work. Force into displacement. Force is measured in Newton. But what is Newton? Newton is kilogram meter per second square. How did I write it? How did I immediately do that? Because I recollected a formula of force is mass into acceleration. Mass is measured in kilogram. Acceleration is measured in meter per second square. Multiplied with the unit of displacement is meter. So what will happen is like how the physical quantities are getting multiplied. the units will also get multiplied. So what will you have? Kilogram meter square per second square. And this is what you technically call it as joule. The replacement of this whole thing is what is called as joule. Am I clear? Like how you replace kilogram meter per second square with Newton, you replace kilogram meter square per second square with joule. Okay. So this is also a derived quantity. If you see kilogram is a measure of mass, meter is a measure of length, second is a measure of time. So now you can ask me a question: is it necessary that the quantity that you are writing, the unit you are writing, should it always have power 1? Meter should it always have power 1? Is it necessary? Look at this one. In a derived quantity, when you write a derived quantity, is it necessary that the fundamental unit should always have power 1? Not necessary. Because when you talk about meter per second square, meter is having power as 1, but second is having power as 2. Do you understand? So there is no hard and fast rule that this is what is supposed to happen. Am I clear with this point? Next is, apart from fundamental and derived quantity, you have something called as supplementary units. So these are the other types of units which mainly have an application in mathematical. So the two kinds of measurements that we are going to see is, one is called as plane angle. So this is what you have been doing on this. So plane angle means we have been doing it already, right? What is plane angle? Basically the angle between two lines. See, for example, I want to draw a circle. What will you generally do? If you want to draw a circle, you will keep the compass here and you will rotate it. So if I want a complete circle, what is the angle to which I need to rotate the compass? 360 degree. Rotate it to an angle of 360 degree. That is in terms of degree. So that is also plane angle only. But there is a supplementary unit where more than degree, right? There is another unit which is derived, which actually measures, which actually does not require a protractor for you to measure the angles. Means if you are able to measure the length of that particular circle, right? Length of the circle is basically circumference. If you are able to measure the circumference of the circle and divide it with radius, then it will give you a quantity which is 2 pi. Because what is the radius of the circle? Sorry, what is the circumference of the 2 pi r? And if you divide it with the radius of the circle that you are trying to, so it comes out to be 2 pi. The 2 pi is called as radian. Means what I'm trying to say is, by rotating a circle, by rotating your compass to 360 degrees, you are able to generate a circle of 2 pi radian. So radian is also the measure of an angle, and what kind of an angle we are talking about? Plane angle. So in the supplement plane angle, that is the angle between two lines. Okay. So I'll show you how to convert from degree to radian maybe in the next class. It's a simple conversion. But plane angle, if somebody asks you, the most standardized measure is what? And it is written as RAD. The symbol used for radian is RAD. Okay. So how to derive that value is basically you take the length of the arc and divide it with radius. So if I take a circle, right, what is the length of the arc? If I take a complete circle, what is the length of the arc? It's a circumference. So basically, if I take a circle like this, if I take an arc like this is the center. Okay, let's say I'm interested to measure how much angle I have rotated the compass for my compass tip, the pencil, to move from A to B. If I know the length of this, which I'll call it as L, and if I know the radius of that arc, if I divide the length of the arc by the radius of the arc, that will give me the angle here, theta. But this time, this theta is not in terms of degree, it is in terms of radian. So why it is useful is because if you see, is it easy for us or using a protractor is easy? Obviously using a protractor is easy, but what happens is, instead of you having that If you know the length of something and you can relate the length, is there a way where we can measure the angles directly? Then this method comes into picture. So that is why you see the numerator and denominator. Length is also distance, radius is also distance. So distance divided by distance is going to give you an angle. Okay. I'll just give you an example. So listen. Try to understand this. If I draw a circle, right, means in terms of degree, how much have I rotated? 360 degree is equivalent to, by rotating the compass to 360 degree, what is the length of the arc I'm able to generate? If this is of radius r, that will be 2 pi r. And if I divide it with r, what will it give me? It will give me 2 pi, and this 2 pi is what is measured in radian. For example, if I give you the radian is pi by 2. Okay, let's make it simple. If I give you the radian is pi, I ask you what is the length of the arc. Will you be able to measure it? There should be some relation. So I know at this point it is slightly tough for me, but I'll use a logic and answer it. So if I'm able to rotate through 2 pi radian, I'm able to get a complete circle. If I rotate through pi radian, how much will I get? I will get half of that circle. So this angle is what is pi radian. How did I get that pi? Because the length of my arc is going to be pi r and my radius is r. So pi r divided by r is going to give me a pi. You're able to understand? So the conversion is very simple. I can actually tell you now itself. 360 degrees is equal to 2 pi radians. So the meaning is, when you tell someone I have rotated through 360 degrees, it is equivalent to creating 2 pi radian. Means if I rotated to 180 degrees, how much radian have I created? Pi. So if you take it as x, there is something called as unitary method. 1 pen costs 10 rupees, 2 pens will cost how much? Right. So how do you find it? You will cross multiply. So 360 into x is equal to 180 into 2 pi. So 180 into 2 is 360. So x will be equal to pi. In a similar way, you can find any radian that you want. If I ask you what is 30 degree, convert 30 degree to radian, and when you do that. So you should start with that. 360 degrees is equal to 2 pi radian. 360 degree is equal to 2 pi radian. Then 30 degrees is how much? Right. Is it clear? Pi by? You know what is the meaning of it? Let's say you buy a pizza. Okay. Let's say you buy a pizza. If you cut each slice, which intersects at 30 degrees, right, you can make it into 6 slices. 6 or 12 slices. So similarly, you want to make a 45-degree slice. Then how many slices can you make? So how did I tell you that it is 12? Because the denominator is 6, no? Into 2. Because you took the reference as 2 pi, think about it, you will understand. Is it clear? So this is how it works. And the last concept for today is the other supplementary unit that we are going to define is for something called as a solid angle, which is defined as the ratio of area by radius square. Which is defined as a ratio of area by radius square. And its unit is steradian. S-T-E-R-A-D-I-A. So to the radian, you add a prefix S-T-E. What is simple? SR. So generally we don't use it much. Okay. So this is all about fundamental, derived, and supplementary units. We have just got started with the chapter. maybe maximum 2 classes will be done with this. But keeping the other parts as a completion or the part, you're able to understand. Things are clear, you're able to think. So is it holiday for you all? Next 2 days, sir. So schools are starting from Monday. What do you start? What about you? You all are from DA. You are from Shankar. You were in Harish. So you are from DA. You all are from. So when is DA starting? 27th. When is it? 27th. Monday, yeah? Monday, what time does it get over? What about you? What time does the school get over? 3 o'clock. What about you? Around 3:30 to 4. Or if there's a holiday, right? Maybe take 1 hour before your other classes, but it's fine. I have enough waiting space. Let's not worry about syllabus completion. Revise this simple. Okay. So we'll have the next physics class on next Thursday. So Monday we'll have Wednesday. So that's it. Any other doubts? Anything more to ask? Clear? Clear, no? This one. Delta has generally changed. Change in value. Suppose you want to measure from initial value to the zero. If you know the final value, then the change is equal to final value. See, for example, initially to 0, finally, let's say it is 10. So what is 10 minus 0? 10. So when the initial value is 0 and final value is 10, the final value is what is the change also. But if the initial value is not 0, you can start at 0, then you start something at 1, and the final value is 10. What is the change? That is the reason why we use it, because we need to understand how much is the radius or area that has been created when the compass is rotated from one particular location to another. So it is not always necessary that you start from horizontal. It is my wish. I will start the point from here. I will keep this as the starting point and I will cut an arc and I will stop it here. So what I measure here is I measure the change in it. Because this value is not 0. This is 0. So this is not 0. So that I think we go change. Slowly you will understand. Okay. So this is called as, if I have to answer more technically, right? Today I was discussing a 9th standard. When I say origin, what comes to your mind? When I say origin coordinate geometry, starting point, generally what do you say? If I ask you the coordinates of origin, 0, 0. But my question is it necessary that always the origin is supposed to be 0, 0? You can have any point. So that's called as shifting of origin. So whenever that kind of a concept occurs, you need to speak about the change of something. So the delta generally represents change. Okay, going forward, remember that I'll explain about it more in motion and state. So is there any other doubt? So it's actually not a big thing that you need to be worried about as at this point. You will understand slowly. Don't worry, it's not a very big thing that you are understand. So apart from that, any other doubt? All are clear? Okay. And I'll see you all on Monday. What's your question?